All righty, folks, how we all doing? All right, today we're going to jump into something called matrices. Now, you may have heard that nobody can tell you what a matrix is, that you have to see it for yourself. Well, today is your lucky day. I'm actually going to tell you what a matrix is. So, a matrice is a whole bunch of rows and columns of numbers. So, in computer language, that'd be a whole bunch of zeros and ones. And if you watch the movie The Matrix, you see all these numbers flowing in all these rows and columns. But really all it is just a whole bunch of rows and columns going side by side by side by side by side. So let's go black here. So it's a whole bunch of information thrown in together. So I'm just going to number these off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So matrices are just a way to put different numbers and different items into some sort of arrangement or array. So really all it is each one of these is some entry. So we pretty much think of this like a big game of Battleship. So the rows are anything that go across. So this would be our first row, our second row, and our third row. And a lot of times we don't say row, we say just R1. Row 1, row 2, and row 3. And then going down, these would be our columns. So column 1, column 2, column 3, and column 4. So column 1, column 2, column 3, and column 4. So we would say then that this right here, this would be a matrix that is 3 rows by 4 columns. Or what a lot of people say is this is a matrix that is what we just call a 3 by 4 matrix. It's a matrix that's 3 rows by 4 columns, or we just call it a 3 by 4 matrix. Now, each one of these things inside here is called an entry. So let's take a look at this entry right here. 8 would be the number that would be in the third row. Let's rewrite that. Probably right here. There we go. 8 is the entry in the third row by the second row. What am I doing here? Second row by the third column. So that would be the entry. So if I say, hey, what entry is in row 1, 4, row 1, column 4, that would be 10. So 8 is in the second row by the third column. So we'd say that this is entry. That would be the entry in the second row, third column. Each one of these is an entry. And they're all, we find them all by the row and column. Again, think of it as Battleship. So the first thing I'm going to ask that you guys do is take a look at these two matrices right here. Determine the dimensions, the rows by columns of these matrices. All right, go ahead and pause. You don't really have to pause the video because I'm thinking you can do it pretty quickly. So go ahead and do it. All right, let's see what you guys came up with. This first one, I have 2 rows. And I have 3 columns. So we would say that this one right here is a 2 rows by 3 column matrix. Let's try the next one. We have 3 rows. And we have 1 column. So we would say that this one right here is a 3 row by 1 column matrix. So we have this idea of matrices, number of rows by number of columns. All right, let's keep going here a little bit more. Right about here. I'm gonna black that out because I want you to see where that came from. Now, if I ask you to deal with and put numbers in an equation into a matrix, we can use it to solve. Now, there's a couple different ways. There's one way called row reduced echelon form. We're not going to do that way. The other way is the Gaussian elimination for matrices. That is the way we're going to do it. So even though your notes talks about row reduced echelon form, I'll tell you what it is, but please realize we're not going to do that. Yep. So an augmented matrix, basically what it is it combines what we call our coefficient matrix with our solution matrix. Now, the coefficient matrix are any numbers, is a matrix made up of the coefficients of the x, y, and z, or x and y, or w, x, y, z, depending on how many variables you have. The solution matrix is all these numbers over here on that side. What an augmented matrix is it basically says, let's put them all together. So here's how we do this. First thing we need is all the coefficients. Any place I don't see a 1, I'm going to add it in there. So, and then notice I have a term that's missing. If I ever have a term that's missing, I got to add a placeholder in here. Be plus 0y. So, and by the way, some of you are going to go, okay, why are we doing this? Realize this is going to allow us to eventually be able to program, and this is why a lot of matrices go with the idea of computers to be able to program software to be able to solve things for us, so we don't have to. Also, if you get to 4 equations, 4 variables, 5 equations, 5 variables, so on and so forth, matrices are a lot better way to solve systems than to actually do algebra. So what we're going to do is we're going to take all these coefficients. So we're going to put all the coefficients on one side. This is called a coefficient matrix. Notice I got that placeholder with the 0. So we're going to take all the coefficients. So we're going to take the coefficient matrix and we're going to combine it with our solution matrix, a matrix made up of all the things that the equations are equal to. Now I put this little green line here to represent where the equal sign was. And we put all the solutions on the other side. All right, so now I want you to take a quick second here and tell me, what are the dimensions of this matrix? Let's see how you did here. Dimensions, just for the fun of it, I have 3 rows, I have 4 columns. So this matrix right here would be a 3-row by 4-column augmented matrix. All right, friends, why don't you go ahead and try this one. Go and pause the video real quick and see what you guys can deal with. All right, so before I do anything, I realized something. I want to make sure that I have all my coefficients in here. 1x plus 3y, but realize I don't have a z term, so I got to add z in here. So 0z. Then I got 0x's, so I got to add in that, minus 1y. So I'm going to expand my equation here. So that way I can see all the coefficients. In class tomorrow, I'll even show you how to use this on your calculator, so that way it makes solving systems really quickly. Equals 0. Okay, so we have now all our variables, all our coefficients, and all our terms, so we can make an augmented matrix. So here we go. All the coefficients, 1, 0, 1, 3, -1, 0, 0, 4, -5, and then we're going to augment it with solution matrix, 9, -2, and 0. So one of the things I also want you guys to kind of take a look at here is that this row right here, these are all the coefficients of x. These are all the coefficients of y, and these are all the coefficients of z. So the first thing we got to do is we got to be able to put something in a matrix. So there we go. Put it in a matrix. And now what are we going to do with that? Okay. So we're going to now go ahead and solve these equations, these systems with matrices. Here's how it works. We have three rules. Three rules to solving any system of equations with matrices. So the first thing we can always do is we can always swap two rows. At any time we want to, we can swap two rows. We can add up the multiple of two rows to replace a row. The last thing we can do is we can always multiply any row by a constant number. So we only have three rules to solve a system of equations. Three rules, that's it. Doesn't seem that hard. So using three rules, I should be able to solve any system. Three rules. Now, we have three rules, but you need to realize we also have a couple goals that we're looking at. So as we go through and solve using our rules, we're looking to take this in steps. The first thing we always have to do. Oh, that wasn't very good, was it? We'll just have to suck it up and deal with it. All right, well, that works. All right, so the first thing we're going to do is we're always going to take it one column at a time. And right now, I'm going to show you what I mean by that. So we have all our numbers. We're going to try to get our first column to be a bunch of ones and zeros. I don't care really what's going on over here. Not yet. Right now, you're probably going, what the world are you talking about? And that's okay. It's going to make a little sense. We're going to do four systems together to try to really make sure we get this down. Okay, so the first thing we're going to do is we're going to try to get that first row or that first column with a bunch of ones and zeros. After we've done that, our second goal is we are going to get a 1 in entry 2, with a 0 below it. And again, we have a whole bunch of stuff going on here. A whole bunch of stuff going on over here. We don't really care about what those look like. And then our third goal is once we've done that, we have our 1, 0, 0. We have our 0, 1, 0. And then after that, actually, we don't care what's above it. The 1 and 0s above it, that's what we call a row reduced echelon form. I'll show you that in a second, but we're doing something called Gauss Jordan. We don't really care. All we care is that we have diagonal row of ones with zeros underneath the ones. And a whole bunch more entries over here. This is going to be what we're trying to accomplish. We want there to eventually be a diagonal row of ones. But we always start on the column to the left, and we're going to work our way to the right. Okay? So let me show you how we go about solving a system. Now, it's going to take a little bit of time, but realize when we get stuck, there's only 3 rules I ever have. So to begin with, let's go ahead and take these. We've solved this system a time or two before. So we already are experts on this one. So the first thing we do is we're going to take those coefficients and we're going to put them into a matrix. if you're a real big fan of these matrices, there's a class you can take. You take it as a math major, you take it as a computer science major. It's called linear algebra. You're a big fan of these. So now I'm going to use little subscripts to kind of help me out so I know which way I'm going. So I already have my 1 up here. So I already have a 1 where I want it. But I want to get zeros underneath it. Remember, we always go 1 column at a time. So I have 3 rules. Swap 2 rows, add a multiple of 2 rows to replace a row, or multiply any row by a constant. So how about if I just add a multiple? Well, 1 multiple is 1. What if I just add the first and the second row together? I'm going to add row 1 and row 2 together. And I'm going to use that to replace the second row. So I have 1, -2, -3, or +3, sorry. 9. All right, so 1 plus -1. When I add the 2 rows, that turns this into a 0. -2 plus 3, that would turn that into a 1. 3 plus 1 is 4. 9 plus -2 is 7. So I added the first 2 rows together and I replaced the second row. Now I need to turn my third row also into a number that starts with 0. So took care of that one. And let's see, I'm going to take, let's take my first row and I'm going to multiply it by -2. So that's a multiple of a row. And I'm going to add it to my third row and replace my third row. And again, I do little subscripts just to kind of help keep me straight. So that way, if I get lost somewhere along the way, I know what I've done. So 1 times -2 is -2 plus 2, that'd be a 0. So we're going to take the first row. -2 times -2 is 4. Plus -5, that would be a -1. 3 times -2 is -6. Plus 5, that would give me a -6 plus 5 would give me a -1 again. -9 times, or 9 times -2 is -18, plus 17 is a -1. So we've finished off the first column. We're now no longer going to touch, as we go to the second, as we move along to that second column, we no longer touch the first column in the first row. So after that, we're going to move to column 2. We don't do anything anymore to row 1 or column 2. They are officially done. We don't touch them. They are gone. Don't think about it. You may want to, don't. We're done with them. We go down to the next one. So we're going to swing over to column 2. At this point in time, if I have to, I would multiply my second row by something to try to get it to be a 1 there. But if you notice, I already have a 1 there. So I'm just going to write it here. So we're looking at it here. I already have a 1 there. So which means that's beautiful. I don't touch the first row in the first column anymore, but I have to make 1 show up here. And I got lucky. There already is a 1 there. So now, if you go back to what we had, our goal, remember what our goal was? I'm trying to get a 0 underneath it. I need a 0 to go under that 1. So to do that, what if I just take my second row and I add it to my third row? And I can replace that third row. So row 2 plus row 3. And I'm going to replace that third row. So 1, 0, 0, negative 2, 3, 9. I got 0, 1, 4, 7. All right, so I'm going to add my second row to my third row. So 1 plus negative 1, well, that would be 0. Well, first of all, 0 plus 0 is 0. 1 plus negative 1 is 0. Now I got my 0 underneath there. 4 plus negative 1 is 3. 7 plus negative 1 is 6. We've now finished off the second column. Some of you are probably going to be sitting there going, seriously, why don't we just do system of equations, man? Yeah, again, when you get to more than 3 variables with 3 equations, this gets pretty nice. Also, like I said, you can program software with this to solve it for you. We don't do anything anymore with row 1 and 2 or column 1 and 2. So we're just gradually working our way down there. And now we're down to that third column, or that third row. And I'm looking at that third row and I'm thinking to myself, what if I were to go ahead and multiply that third row by 1/3? If I do that, that'll put a 1 where the 3 is, and I'd be all done. Because I'd have my diagonal 1s with my 0s underneath. So the nice thing is, again, we have only 2 or 3 rules the entire time. And as we go through, it keeps things very, very organized. So I'm going to multiply that third row by 1/3. So 0 times 1/3 is 0. 0 times 0 is 0. 3 times 1/3 is 1. So we're essentially just dividing by 3. And 6 times 1/3 is 2. You can see all the diagonal of 1s. There's 2s below them. Now this is where this gets really cool. Remember what these columns represented. These were our x's. These were our y's. And these were our z's. So at this point in time, we're going to turn everything, we're going to turn our matrices back into our equations and solve the system. So we're going to turn matrix back into a system of equations and solve. So our first row, that doesn't do anything for us. I had 1x minus 2y plus 3z equals 9. I had 1y plus 4z equals 7. And I had 1z equals 2. Notice, when we turn it back, it makes it something that's really user-friendly to solve for x, y, and z. Matter of fact, I already have z. So I'm going to just work backwards now and plug everything in. So y plus 4z equals 7. So y plus 4 times 2 equals 7. So that means y is -1. We plug in our values now in for the y and z in the other one. X minus 2y plus 3z equals 9. So y was -1. Z was 2. And when you solve it, we get x equals 8, or x equals 1. And we end up with a real nice user-friendly way that we could actually program some sort of software to find the system of equations for us. Okay, so what we're gonna be doing pretty much the next rest of the little bit is we're just gonna practice this, because guys, let's not kid ourselves. This is gonna take practice. Okay? You're eventually gonna get to a point you're gonna be like, okay, I get what's going on. You may not necessarily like it, but you at least will understand what's going on as we work through it. Okay, so I'm gonna go ahead and clear our drawing here. And we're gonna move on to our next one. By the way, here's what row reduced echelon form is. And it's what I told you we're not going to do. Notice row reduced echelon form. You still have your diagonal ones, but notice you have zeros below it and above it. And the nice part about this then is it says z equals this, y equals this, x equals this. The nice thing about row reduced echelon form is it tells you exactly what everything is. But we're not going to worry about the zeros above our diagonal ones, just below. So we're doing what's called Gauss Jordan reduced echelon form. We're not going to be going through and doing full row reduced echelon form. All right, friends, go ahead and start off and turn this into a matrix. Let's see what you guys get. All right, let's see here. How did you turn into a matrix? So the first thing is, can we just turn it into a matrix correctly? 2, 1, 2, -1, 1, 1. We have 4, -2, 2. Okay, notice we already got our 1 where we want it to be. That's good stuff. So why don't you guys pause the video and get just the first column done. Pause the video, get just the first column done. Unpause it when you've done that. All right, let's see how you did here. So I'm going to take -2 times the first row. And I'm going to add it to my second row. And I'll replace the second row. So that doesn't change, that doesn't change, that doesn't change. That doesn't change. It's the second row that I'm going to change. All right. So I got a 0 here. I'm going to have -3 here, because again, I'm going through and I'm multiplying everything by -2 to add to my second row. So -3, oh, what's that going to be? -2, that'd be, take a look, what is that? 2, that'd be 3 as well. -12, -2, -8 plus -2 is -10. All right. So we go ahead and we erase it. Now, we didn't touch the third row yet. We try to take it only one row at a time. Don't get ahead of yourself. All right, so now I'm going to multiply that, or get a row of zeros now underneath that there. On my third row, I need a 0 in that first entry. So I'm going to multiply -1 times row 1. And I'm going to add it to row 2. 3, row 3. Here we go. So 1, 2, -1, 4. I already played with the second row. That one's going to be gone. And now when I do the -1s here, I'm going to end up with 0. I'm going to end up with another 0. That's kind of cool. And then I'm going to end up with 2 and a -2. Okay, so I'm done with the first row, or first column. Now I'm going to go to the second column. So I'm going to start off, I'm going to multiply my second column by 1/3. My second row by 1/3. Replace it. So we won't touch that first row again. And if you notice here, I am going to end up with kind of an ugly fraction here. So I got to multiply that by -1/3. Sorry about that. All right. So I get 1, I get a -1, and then I end up with 10/3. I'm not a big fan of the fraction, but it is what it is. Notice I already got a 0 underneath my 1 in my second column, so I can just move right on down to the third one. I don't have to stay there. And by the way, if you notice, guys, I use a different row for myself on my paper. I don't usually keep going across. Again, I do little things like this just to help keep me organized, because I know me. I know that when I start going, it's very easy for me to kind of lose track of what I'm doing here. And I just find that this is easier for me to do this. That's 10/3. And when I multiply that bottom row by 1/2, I get 0, 0, 1, and -1. So turn it back into a system. X plus 2y minus z equals 4. I get y minus z equals 10/3. So I am going to be dealing with a fraction here coming up. And I get z equal to -1. So a real nice cut and dry way for us to figure out what our variables are. And know that it's always going to pop out and work for us. So y minus, I'm going to plug my -1 in there. So that's y plus 1. That means y is going to end up being equal to 7/3. And we go to our last one here, x plus 2y minus z equals 4. So I plug my numbers in again. There we go. I get a 7/3 here. And I get a -1 here. And we find out that x, when you clean this up all the way, you get -5/3. So -5/3, 7/3, -1. All righty. Again, this just takes practice. So why don't you guys go ahead and pause the video, try the next one here. Try that next one, see how you guys do. All right, let's see how you guys did. All right. So first things first, always set it up. Like I told you, this is all we're doing today. Okay. Just getting used to solving systems, but this time solving systems with matrices. All right, we got 1, 2, -3, -2, 1, 2, 3, 1, -2. There's my augmented matrix. Again, I got it lucky I have the 1 up in the top spot. I kind of like that. All right, so if you didn't get here, go ahead and pause the video from here now and see if you can't get zeros underneath that 1. All right, so I'm going to have -2 times the first row plus that second row, and I'm going to replace that second row. And again, you don't have to put the red subscripts like I do. I just do it because it saves me. If I make a mistake somewhere, and friends, you've been with me long enough now to know that sometimes I tend to make a little arithmetic mistake here or there, or sometimes I just, especially writing with a mouse, I can't read my own handwriting. So sometimes it happens. All right, so we end up with 0. We end up with a 5. So -2 times -2 is 4 plus 1. -3 times -2 is a -6 plus 1 is a -5. 4 times negative 2 is negative 14, plus 4 is a negative 10. So negative 3, 2, negative 2, negative 10. So we go 1, we're doing that first column to begin with. So this time I'm going to take 3, and I'm going to multiply it by my first row. And I'm going to add it to my third row. And I'll replace that third row. And again, friends, notice, we're only using 3 rules. Although, I'll be honest, we've only used 2 rules. I have yet to do a row swap. Really, all we've ever done is add, replace multiple of rows, and then multiplied a row by a constant number, or essentially we divided. We're always multiplying by fractions. All right, so now I'm going to multiply that top row by 3. So 3 times 1 is 3, plus negative 3 is 0. 3 times negative 2 is negative 6, plus negative 2 is negative 4. 3 times 3 is 9, plus negative 2 is 7. 3 times 7 is 21, plus negative 10 is 11. All right, friends. Now, if you need to, pause the video here and work to get that second column done. Get the second column done. All right, let's see how you guys did. All right, again, we don't touch the first row. Once we get a 1 where we want it, we don't touch that first row. So for me, I'm going to start off by multiplying that second row by 1/5, or dividing by 5. So that would give me 0 times 1/5 is 0, 1, negative 1, and negative 2. All right, we're getting numbers that are just a little bit more user-friendly. I like it when I don't have to deal with fractions. All right, so now I'm dealing with the second row, and we're going to try to make 0 underneath that 1. So I'm going to take my second row and multiply it by 4 and add it to the third row. So I got 1, negative 2, 3, and 7. 0, 1, negative 1, and negative 2. And underneath that, I have, what do we got there? Now I have 0, 0. Negative 1 times 4 is negative 4, plus 7 is 3. Negative 2 times 4 is negative 8, plus 11 is 3. Okay, so I'm done now with the second column. We're going to move our way on down to the third row. And I'm going to take that third row, and I'm going to multiply it by 1/3 to get what I want. So like I said, we're going to do a few of these here because I'm hoping you guys kind of start to see the little process here. It can be a little time consuming, especially when you're writing with a mouse. We could be going a lot faster with pens and paper and all that kind of stuff. That's not a luxury I get to have right now. So we multiply that bottom row by 1/3 and we get 0, 0, 1, and 1. So we got all our 1s and 0s now. So we turn everything back into a system of equations. So x minus 2y plus 3z equals 7. Y minus 2z equals negative 2. And z equals 1. Plug it back in. So I'm going to plug it into this first one here. So y minus 2 times 1 equals negative 2. Oh, couldn't read my own handwriting, can I? Telling you, that's the problem with sometimes dealing with a mouse. There we go. I'm gonna say something didn't match up my number. That was supposed to be a 1 right there. So that was a minus z. There we go. Sorry about that, guys. So y minus z, y minus 1. So y minus 1, we plug it in there. We're going to add 1 now to both sides. And we end up with a negative 1. So y equals a negative 1. And now we plug it into our last one, x minus 2y plus 3z equals 7. So plug our numbers in here. Y was negative 1. Z was 1. And we plug it all up, we get x equals 2. So 2, negative 1, 1. All right, friends, you've done pretty good so far. Pretty good so far. One final one for you here. We're not going to do that problem. I got a better problem for you. Let's kiss that one goodbye. There we go. All right, so here's the problem I'm going to give you folks. Last one of the day. Let's see here, 2x plus y minus 5z equals negative 21. X plus 2y minus 2z equals negative 15. And our last equation is going to be x minus 4y plus z equals 18. All righty, friends. So let's see how you guys deal with this one. Yep. There is going to be a little tough part coming up somewhere along the way. Let's see if you guys can figure that out. Good luck. Pause the video or watch me do this while you pause the video. We'll come back and do the last one together. All righty, here we go. Matrix. I got 2, 1, 1, 1, 2, negative 4, negative 5, oh, negative 2, 1. One of the things I like about this is there really is no right way to solve these. And you got your rules, and that's about it. As long as you stick to that, the order you go in is fine. But now I'm looking at this for the first time. I'm looking at it going, ooh, I can do a little row swap. I'm going to swap row 1 and 2. Just kind of help myself out there a little bit here. I do not like the way that's set up. Undo. If I do that, maybe I'll help myself out. Maybe I won't. Maybe I'll make it tougher. Who knows? I could have subtracted the first 2 rows and replaced that top row. I could have done that. Let's just try this. I also could have swapped the first and the third row too. Could have subtracted the first and the third row and replaced the first one. There's a lot of things you guys can do. I mean, there's 4 things you could have done here right at the very beginning to make this work. I just haven't done a row swap yet, so I thought it might be fun to do one. 1, negative 5, negative 21. All right. So we'll let this be the matrix I play with. All right, I'm going to multiply that top row by -2 and replace and add it to the bottom row, or second row. And we'll replace that second row. All right, we get a 0, we get a -3, we get a -1. Well, that's not pretty. And we get a 9, -3, -3, -1, 9. That is definitely not pretty. All right, we'll see what the second one ends up being. Maybe we can make this a little bit better on ourselves. Maybe we can't. You never know. So sometimes you got to get a little creative if you can't. Hopefully that's not the case. So -1 times R1 plus R3. One, 2, -2, 15. All right, let's see here. I got 0, -3, -1. Didn't like those numbers. Hopefully these numbers are just a tad bit better. All right, so 1 minus 1 is 0. -2 minus or plus a -4 is a -6. -2, that's +2 plus 1 is 3. Oh, these aren't much better either. 30, 48. No, that can't be right. 33. Yeah, these are definitely not much better. All righty. So somehow I got to take that -3 and that 6, and I got to turn it into a 1. So I could divide by -3. I really don't want to because that's just ugly. So what if I take that -3 and I multiply it by 3? That'd make it a +3. And what if I added 1/2? Again, I'm just playing with numbers, trying to figure out how I could possibly make that into a 1. And if I were to take that, it would have been 3 minus, what if I made that a 1/3 there instead? So -2. Okay, that would have done it. If I take the second row, multiply by -1, and add 1/3 of the third row, that would give me a 1 there. Wow. All right. So that's going to be what I do. Remember, I can multiply both things. Sometimes you got to get a little creative. Not very often, but this time I have to. So I'm going to take my second row. I'm going to multiply by -2 or -1. And I'm going to add it 1/3 of the third row to it. Just get a little creative here to make this whole thing balance out for me. Whew. All right. Sometimes you got to get just a little creative. Either that or you deal with fractions, and I'll be honest, friends, I don't really want to deal with fractions. Chances are you don't want to either. So if I can get a little creative here at the beginning, then maybe, just maybe, I might be okay here. So -6. Because it'll make my numbers later on where I don't have to use fractions later on. Once I introduce fractions, I'm using fractions. I really don't want to. So I've already seen now this is going to be 0. That was 1. Let's see how my little formula here would have worked on my next numbers. So negative times the -1 plus 1/3 of 3. That would have been 2. Okay, so that worked okay. What about my last numbers? Hopefully we're good there too. So negative times 9 plus 1/3 times 33. That would have gave me 2 as well. All right, so again, sometimes you got to get a little creative. It's a little ugly, but if it works out, you set yourself up later on for the rest of being perfectly good. So now I'm going to take 6 times the second row. And I'm going to add it to the third row. I'm curious to hear from you guys tomorrow what you guys ended up doing this one. Did you guys use fractions? Did you, maybe you started off differently and made it look a little bit better? Could have done that. So we got 1 there, we got a 2. The numbers definitely do work out pretty well once you get past the grossness of it. So you got a 0, you got a 0. All right, 2 times 6 is 12, plus 3 is 15. 6 times 2 is 12, plus 33 is 45. Oh yeah, this is gonna work out really nice, friends. So we're gonna take that 1/15 now times the third row. Sometimes you just got to get a little bit creative with it. All righty. You guys are doing well. I warned you earlier today, this was going to be another one of those long ones. I wish it wasn't. When you're dealing with augmented matrices, friends, there's just no way to make it terribly short. The good news is the next 2 days will be shorter. All right, so what do we got here? We have x plus 2y minus 2z equals -15. Y plus 2z equals 2. And you get z equals 3. All right, let's plug those in then. So y plus 2z. I do like that the numbers eventually work out being pretty nice. Kind of a good little lesson there, friends. Don't ever give up on something. Right? Maybe it's going to be a little bit harder. Maybe it's going to be just a little bit not what you're looking for, but don't give up. You can persevere through it. You guys can do amazing things. And then our last one here, x plus 2y minus 2z equals -15. So x plus 2 times -4 minus 2 times 3 equals -15. So we plug in our numbers here, and lo and behold, we end up getting that x equals -1. So -1, -4, 3. All right, friends, you guys are troopers. You did well, you lasted. Okay. So we'll talk tomorrow. We'll spend a little more time kind of going over this stuff tomorrow. Make sure you guys got a kind of grasp of it. But nice job staying with me, and I will see you in the morning.